Hello, everyone. Got an exciting talk for you today. Hope you're all energized. Last presentation. Uh, yeah. We're going to talk about combining genericized graphical representations of G and Markov chains, real-time offline next block prediction with support for rapid returning upon dependency changes. Right? Everyone gets that? All right. No. We're going to be talking about LabVIEW Autocomplete. It's old-fashioned AI in quotation marks, for faster coding. So, I mean, the AI here is so simple that I had to put it in quotation marks because you're going to be uh, amazed by how simple the idea is in concept. It's so simple you could even do it on pen and paper instead of these transformer models that are all these neural networks and stuff. So the goal here is, by the end of the presentation, I will show you a tool that suggests your next block for you while you program. It's going to be blazing fast. The predictions will happen in milliseconds. Uh, the the tool the tool will run entirely on your device. It only takes uh, a few megabytes of your RAM and your storage, and it will support all of your custom libraries uh, very easily. I'm going to show you how I made it and how you can use it. So a little bit about the company. I work for DMC. We do a lot of different test and measurement work, but you might know us from your front panel. We have the DMC GUI suite and the UI styles toolkit, which I think are some of the most popular VIPM packages. A little bit about the company. We have about 290 people. We do some work with PLCs, SCADA systems. We have a panel shop that's expanding, work in Chicago, and we have a few offices outside of Chicago. I work in the Houston office. We have CLAs, CLDs, CTDs, two LabVIEW champions, you might know them, Kevin Shirey, Chris Cellino, and we are a certified N.I. Center of Excellence. So a little bit about me. I'm a systems engineer at DMC, certified test stand developer, and I got my Bachelor in Science in Electrical Engineering from Rice University. And while I was at Rice, I took a few computer science courses and machine learning courses, which I think give me kind of a fresh perspective coming into the LabVIEW community. I also, fun facts, I like to work on projects that I think are cool or interesting or practical. I used to make escape rooms in college. So this is a little picture of an escape room that I worked on. At Rice, there's a building that looks like a toaster. So I made a toaster shaped like the building. And also started making things that are a little more practical for work. I made a website that lets you explore, run through these TDMS files, CSV files, without installing anything on your computer. So practical, interesting, fun projects. And I had some time at the end of last year where I wanted to work on something new and apply all these concepts that I'd been learning in school and learning in my job. And I was interested in the idea of efficiency. So I know that it's kind of the engineer's code to do things efficiently or lazily. And I wanted to kind of work from that principle. I also know that there's a lot of AI hype happening right now. Everywhere you look, people are talking about the next new ChatGPT wrapper. But these kind of tools are difficult to apply to graphical code in kind of a meaningful way. And big shout out to JKI for Jake AI and NI for Nigel. Wonder how they came up with that name. These are really cool applications that use transformer models, ChatGPT, but actually engaging with graphical code in ways that are really interesting. And I'm excited to see what happens with that. Going to download the 2025 Q3 later today. Finally, I had an idea involving Markov chains, and I couldn't get it out of my head. So I'm going to tell you what Markov chains are in a second. Yeah, what is a Markov chain? It's basically a way to model something that is represented or can be represented as a sequence of states. So you have something that has X state, then Y state, then Z state, and you can make the assumption that the most recent states are predictive of the next state. So one example of this is maybe you're playing rock, paper, scissors against a friend of yours, and this person is maybe a little bit predictable. You notice that whenever they play rock, then paper, then scissors, about 60% of the time, they play rock. 30% paper, and maybe 10% scissors. If you're playing against them, you can make a model of how they're playing by just recording they play paper, then scissors, then rock. And then you can say, okay, 60% this, 30% that. And then you can play against them. You would play paper and win 60% of the time. You can apply the same concept to the weather, sunny, cloudy, rainy. You can apply this if you're thinking, where do I want to eat today? I had Italian food, then Chinese food, then Indian food. Where am I probably going to want to eat? Probably Mexican. So what does this have to do with LabVIEW VIs? How do you convert a LabVIEW VI into a sequence of states? Well, first, you have to think graphically. In computer science, there's something called a computer science graph, a computational graph. And what is a graph? It's just what you have on the top right corner of the slide. It's nodes connected to each other by edges. And that's really as simple as it is. LabVIEW, if you look at it, if you squint, looks like a graph. But how do we treat it like a graph? How do we make that graphical representation? First, we ignore structures. They're inconvenient to what we have to do, so we'll pretend like they don't exist. Then we genericize the blocks. We basically find a way to take every block we have in the diagram and pretend it's just a thing that can be represented uniquely as some string that's unique to it. So we had a numeric control, we just say it's numeric control as a string. And we do that same principle for all the other blocks. Then we start to count 2-block sequences. So you'll see in the top left, we've got a numeric control followed by a DACMX create channel analog output voltage basic. And you see that again. And then you see an IO control followed by DACMX create whatever. And so we could turn that to our table. We have block 1, block 2, and the count. And we can do this with VI scripting, as we learned yesterday. I've got the traverse for G objects that I learned about. I actually, yesterday, fixed this. I was doing it in an inefficient way, and watching Darren Nattinger's presentation helped me do that correctly. Thank you. So we do that for more of the blocks. DACMX create channel analog output voltage basic is followed by DACMX timing sample clock. And I'm not going to repeat myself over and over again. We do this for the rest of the VI. We have this nice table. What do we do now? We convert it into our model. We have a key value mapping where the key is going to be block 1, and the value is going to be an array where each element in the array is a block that potentially follows, and then the count of how many times we see it following the block 1, or the key. So for example, we see numeric control followed by DACMX create channel twice, and we see numeric control followed by sine wave 3 times. And we build our map and we sort in descending order. So we have the most relevant, most frequent predictions at the very top. Now, let's make a few predictions. What would you expect based on our single VI model to follow a numeric control? Anyone? Sine wave. Yeah, that's correct. Give yourselves a pat on the back. So we see the sine wave 3 times. So that's probably what it is. The DACMX stop task is followed by, in our model, the DACMX clear task once. That's about it. So we don't have a very generalized model, but we have an approach to start to build a generalized model. So we take the same table to map approach. We do this not just with one VI. We do this for every single example VI we have on our computer. So you guys might recognize the NI example finder. I just looked at the folders where these examples are mostly stored, and I ran through every single VI and made a table, and then added up those tables, then converted that to a map, and I created my model. So I'm going to give you a live demo now of what that looks like in practice. So we've got, show you. Got a block diagram editor, and I'm going to launch the autocompleter. Okay. Let's say I am doing some file operations. I'll drop the open create replace file block, and it's going to make a prediction the moment I click on it. So I click, and then instantly, in just a few milliseconds, because it's just an O of 1 time complexity. It's a computer science thing. O of 1 time complexity map lookup. It's instant. Maybe I see, I want to drop the read from text file, and it drops it right next to it. Maybe then I want to close my file. I don't know, maybe I want to drop an error handler, and that's just a typical workflow. Can also do some auto wiring. This actually uses behind the scenes the quick drop auto wire feature, so it's not perfect, but it's pretty good. Automatically wires it. Yeah. Thank you. Anybody else want to try a VI of their choice from my palette? Any suggestions?
Sound API. Let's record the microphone.
Sound API. Okay. What are these blocks? Input. Okay. This, if there's an example for it, then it'll. Oh, not the Express VI. Oops. Sound. Put. Configure. That's it. Okay. We have predictions. Drop that in. Automatically wires it. And sound file close. Yep. So yeah, it even works for your own custom libraries, as I said. DMC has some internal tooling that handles test stand, for example. And let's see, we handle the lifecycle of test stand pretty neatly with these internal tools. And we have our own programming pattern in which we use them. So we start test stand, then we might construct. Okay, so it's taking a second because it's importing the test stand module, and then it's going to drop it. There we go. And we initialize, maybe subpanel. We terminate the module. This is basically the flow in which we typically use this specific class, and then we might dispose of it. So, go ahead.
If a lot of times when you're doing these patterns, you have a while loop or something. So does it continue to predict even if you place a VI, then you draw a while loop, and then it'll predict based on the last VI or based on the while loop?
So the thing about this is right now it's set up to work with a Markov chain of order, I think 1, which is just the VI you've clicked on. It has some programming in it right now that could let you use the VI and the previous VI, but it's not really fully tested yet with that sort of thing.
Can you update the statistics for it by adding your own code, for example, at any moment in time?
Sorry,
so
go ahead.
I had my own class.
Okay.
your app never seen it. It cannot predict what I want, right? So can I give it incrementally some more training material for it to collect the statistics?
Yeah, so if you were to add a new folder that has an example file that uses your class the way you do, and you run the training process again, it will, because it caches information for files it's already gone through, it'll go through all the files it's already trained on very quickly, and then it'll hit the file that you just added, and it'll run through it.
So you can perform augmented training anytime I
Yes.
want.
Exactly, yeah. Go ahead.
You said for things like structures, it removes it to do the analysis. If you have like a case structure or something that has multiple frames, is it considering all of them in the way you trained it, or is it just doing one of them?
So what it does is it has an initial stage where it takes every wire using traverse, and it sees if one of those wires is an input or an output terminal through a case structure or a for loop or while loop. It, in a cleanup stage, will look for the block that follows that, and if that's a block that it can index, it pretends it, for every block that follows, it makes an additional example wire. So if you have a block wired into a case structure and then block A and then block B in a different diagram, it takes both of those cases into consideration. As far as theoretically, I mean, I haven't tested every single case, but that's how I believe it works. Yes.
So you have this with an order of operations of left to right. Basically, it's following the data flow.
That's right.
Did you think about doing it without the data flow direction? So you would drop like a ramp and expect that the next thing you want to drop is a constant, for instance, as opposed to if you drop the constant first, who knows what you're going to want to follow that?
I guess you could do that. I haven't set it up that way, but I think this is kind of scoped down as a project so that it takes the easiest case, which is theoretically you're just programming block, 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 left to right. But I think that that could be a useful way to do it. Yeah, one more question.
Is this open source, and are you open to contributions?
It's open source, yeah. And thank you. All right, gotta get back to the, oh, sure, yeah.
I mean this in the most possible respectful way, so don't take it wrong. Is this useful in real life to you?
I've wanted, so the last LabVIEW project that I've been working on that's kind of major is this, and I've wanted to have this while programming it. So I can understand that like this interface on the left with the block thingy is not the most optimized way. I'm open to hearing other suggestions of how you would want to use it. Another way to use it, I was thinking, was with quick drop. Quick drop.
I'm feeling lucky. Quick drop, I'm feeling lucky.
There we go. So you can actually, it's integrated with quick drop right now, but this is kind of a very early beta kind of feature. So maybe that's another way you want to use it. Yeah. Okay. Usage modes. I went over this a little bit, but right now there are two ways to use it. The one main way is with the dialog that has your suggestions. The other way is with quick drop, but use at your own risk. Yeah, I'm looking at other ways of possibly integrating it. The advantages, again, are that the predictions are super fast. It's a simple map lookup. It's just O of 1. It runs way faster than your transformer models because you're not tokenizing, converting into an embedding, running it through a neural network, producing token, converting back into a G value or object or whatever. So that it's way faster. It runs on device, CPU. It can run in your virtual machine, no sweat. You have full code privacy. Nothing ever leaves your computer. It just runs everything inside your VM. And the process for training is additive, which means that you have all your cached representations of your files. And if you delete an example, it doesn't have to retrain minus in, it doesn't have to do anything other than just like work with the files that's already cached. So deleting example, retraining is, seconds. Adding a file, seconds, plus the file you just added, which will take probably a second or two. And yeah, disadvantages, the suggestions are less complex than transformer models. So if you really want a good, contextually relevant snippets of code kind of suggestions that take into account the rest of VVI, this will not replace something like Nigel or Jake AI. I'm not sure of the full feature set, but those will always suggest more contextually relevant suggestions. It doesn't generalize as well, and yeah, less contextually relevant. But future possibilities, I think, if a library that's hosted on VIPM had more examples, it would be much more easy for this to immediately be able to work with it. And if you're using an unfamiliar library, it'll be really easy to just like download it and start using autocomplete on it. Maybe if there were pre-index weights per library, you wouldn't have to go through the training process and kind of take up time. The biggest disadvantage is the training process. It does take a long time, but luckily you can run it on a machine that's performant, highly performant. Take the data and just copy paste it into your VM and have your training done for you. And I think in the future, maybe more usage modes could be explored. So I tried playing around with a palette that dynamically updates as you like click on blocks. I think this would be maybe a more useful interface, but unfortunately, the refresh palette seems to close it every time I refresh it. So I'm still playing around with that and seeing what else I can do. But maybe you guys in the community can find more ways to integrate this. It's fully open source. Yeah, the instructions to train and run the app are including the README, including the quick drop integration. Again, use at your own risk. Yeah, let me know if this seems helpful, if you think you have any other suggestions of how you'd want to use it. And yeah, I'm going to leave it up on the screen for a little longer, but any more questions? Yes.
You said it takes a long time to train. Is it like hours? Is it, several minutes? Like what's long?
Yeah. So yesterday I made an update and I thought, okay, I should probably retrain this, and it took a few hours. So the training process is such that if you like stop and then you start again, you can stop at any point and it'll basically just resume from where you stopped. So if you get interruptions and stuff, it'll just work very easily. But it does take hours, even on your host. So just be aware of that. Yes.
I'm on your GitHub repo here. Why do you have a dependency on the report generation toolkit? What are you using it for?
Yeah, so the images that show up when you're, these images, to be able to cache them, to be able to use them while you're getting suggestions, I needed to be able to screenshot them. The way to do that conveniently is with the report generation toolkit. I'm open to hearing if there's like another way to do it, but this is what we have for now. Looks like I'm out of time, but yeah, thank you guys so much. And